Okay. So 3 variables. This very first example, is solving by something called back substitution, which you are going to use in all the other examples. This one's just set up really nicely. Do back substitution. You see how we have our 3 equations, and in our third equation, z is 2. So when I go to find my ordered triple, I already know what the z value is. So using back substitution, if I know z is 2, I can substitute in z into equation 2. So equation 2 I'm going to rewrite as y plus 3 times 2 equals 5. And solve that so I get y is -1. While I'm doing notes today, I'm going to try to not say every number as I write it, because when you're writing numbers and I'm writing numbers at a different pace, then you end up writing the number I'm saying. You ever have that happen? So I'm going to try to not repeat every single number as I write it like I normally might. Just if you need to see what I'm doing, just look up here. If I'm going too fast, just tell me. One more thing, if it's if I'm writing off the screen, let me know. Okay. Sometimes I forget to look. All right, so now we know z is 2, y is -1. We can plug it into equation 1 and find x. Oops. Anybody ever made a silly mistake in here? Well, today's the day you're probably going to have chances of doing it. Let's just try to take our time, make sure our handwriting is legible, because today might be the day that you make silly mistakes. Also, today's the day you don't want to make silly mistakes. You'll see why. But here's my ordered triple, my 1, -1, 2, and we write it in parentheses just like an ordered pair, just x, y, z. That one wasn't too bad. Example 2. What'd you say? When we solve with these, you can only use 2 equations at a time. Is that what you were saying? Yes. So you can only use 2 equations at a time. Before you even just jump on in and start, our goal is to get 2 equations with 2 variables. Because if I can get rid of one of the variables, if I can get 2 equations with 2 variables, then I can just do elimination or substitution like I did last night. Because that's what we had, 2 equations with 2 variables. So that's my goal. You can only eliminate or use substitution, which we're going to use elimination. We're going to only use elimination with 2 equations at a time. So look carefully. Look at all 3 equations. Look at the x's, the y's, and the z's. And which variable would you like to try to get rid of? Look at the x, y's, and z's. And there's no wrong answer. So I've heard basically all the letters, but I heard most z's. So let's do the z's. If you look at equation 1 and equation 2, the z's are already set up to eliminate. So let's eliminate z. We're going to eliminate z from equation 1 and equation 2. Now when I did that, I want to point out a couple things I've done. I've rewritten equations. I've tried to write them as clearly as possible. Notice how I've got funny line in my z's and my 7's. Why? Yeah, because I have graded so many papers in my life where somebody had a z and then thought it was a 2. And they got so lost because they couldn't figure out what they did wrong because they couldn't read their own handwriting. So I have changed my handwriting over the years to make sure that my Z's have the line in it. I would encourage you in this class to make things obvious. Like sometimes people think Y's are 4s. So I take my Y's and I curl them at the bottom now. I've changed my handwriting just to make it easy for math. Another thing is I labeled this equation A because as we're doing the notes today, I'm going to be making notes like, plug this in equation A, so that when you go back, you don't have to do all these labels, but when you go back and you're trying to decipher your notes, it might be helpful. So if you're not writing everything that I'm writing down, you're not going to necessarily be able to figure it out later. So I'm just trying to help you as much as possible for the future. Okay, so I eliminated Z from 1 and 2, and I called that equation A. Now, I need 2 equations with 2 variables. So we're going to repeat the process. We're going to repeat the process, but you have to eliminate Z again. It cannot be a different variable. It has to be Z. And we can't use 1 and 2. We can use 1 and 3, or we can use 2 and 3. 2 and 3? What should we multiply 2 by? Make sure you multiply all terms, or you will have a mistake. You won't know your mistake until you've done a lot of work. So I'm going to refer to that equation as equation B. We got 7x plus 7y equals 28. That's equation B. We now have equation A and B. Both of those equations are 2 variables, the same 2 variables. So what we do now, I'm just going to rewrite them. You certainly wouldn't need to, but I'm doing it for notes purposes. I'm doing it so you can decipher later what you did. So now we're going to look at these 2 equations and decide to either eliminate x or y. So we have 3x and 7x, or we have negative 2y and positive 7y. What should we eliminate? There's not a wrong answer. What should we eliminate, though? The y's? Okay. There's not a wrong answer. There's not. But the reason why I chose y is I already have 1 positive and 1 negative. We are going to have to multiply both equations by something. So I'll multiply A by 7 and B by 2. So after I eliminate, I get 35x equals 105. Now I've eliminated 2 of the variables. I have only 1 left. I can solve that. We can find x. So divide by 35. X is 3. And if you need to pull out your calculator, divide 105 by 35. That's okay by me. When we have 1 answer, we will use back substitution. The back substitution cannot go all the way to the beginning. It can only go back a step. So we're going to go back to either A or B. So you either plug it into A or B. And I'm writing on here plug into A or B, but if I were doing my work, I would actually just write plug in A. Yes? It does not. But when I look at my 2 A's, I'm going to plug in the one that has less, like lower numbers. That's what I would do. So I am going to plug it into A. You can plug it into B, but A has lower numbers, so I'm choosing A. And I solve for y. And I get y equals 1. So we went back to A or B. At this point, when you have two variables, then you go back to 1, 2, 3. So we're going to go and we're going to choose, it does not really matter, I'm just going to go plug it into 1 because it's the first equation. I'm going to plug in x and y into equation 1. If you did all of that stuff and somehow there was a negative you missed in there, it is very possible you'll get an answer, but you won't know if it's right. So we will check our answers just like we checked our answers last night in the assignment. Where yesterday's assignment you would plug in 1, check in 2. Now we plug in 1, we check in 2, and we check in 3. You gotta check in all of them. So we're gonna check in 2. And check in 3. If it checks, then you can write your solution as an ordered triple. If it doesn't check, what's that tell you? And just looking at how much work I did, how much paper I used, how much space I filled up, I hope that you do not rush through it or read your handwriting wrong and make a silly mistake and not find out till the very end. Right? So take your time. I've only given you 8 questions for homework, so take your time so that we can avoid some of those silly mistakes. That probably will happen no matter what. Okay. Rain break? Yeah. All right. So example 2, we're looking carefully and we're going to decide which variable we want to eliminate. The goal is to get 2 equations with 2 variables. So when you're looking at these equations, you see one of them is kind of special. That third equation, equation 3. Why is equation 3 so special? What's already eliminated? The y is already eliminated. So if I use example or equation 1 and 2 and I eliminate y, I will already have 2 equations with 2 variables. So it's just a little bit less work. So I'm going to eliminate y from equation 1 and 2. That means I'm going to multiply equation 1 by -3. So I get equation A, -4x minus z equals -17. Equation B, I'm just going to take that third equation and reorder it so it lines up with equation A. It's going to reorder it. So I'll move the 4z over. I'll have x minus 4z equals 0. Now we have two equations with two variables, so which would we like to eliminate?
X.
Yeah, the x. That sounds good. By the way, before I do go on, you don't have to use elimination. You could have done substitution for this one since it was already solved for x. You could have done substitution instead. I'm just trying to keep it consistent and do the same thing over and over again. But if you're sitting here thinking, well, why didn't I do substitution? Like you totally could have. And you're more than welcome to try, using substitution at any point that you'd like to. All right, so we're multiplying b by 4, right? That's what we're getting rid of, right? Yeah, okay. I solve that and I get that z is equal to 1. And then we use back substitution. So we go back a step. We go back to either A or B. And I look at A and B and it does not really matter which one we plug it in. B would be fine. Is that okay? Yeah. You could. We could plug it in 3. You gonna do 3? We have to do 1, 2, and 3 at some point, so should we just do 3 now? Okay, let's do that. All right, so we plug it in 3, and we'll have x equals 4 times 1, so x is 4. There are many different orders of how you could do these. Yeah, we can plug in 1 or we can plug in 2. There's lots of different orders. So because there's so many different ways you could do these, if you would like assistance, if you get stuck on something, it's got to be organized if you want my help. If I'm going to look through all your work and try to find your mistake, it's got to be organized. Just heads up. I would love to go through all your work with you and help you find mistakes, but I got to be able to figure it out. All right, so we're going to plug in 1. So I get what y equals, then we'll plug it in 2 to check. And it should work, so you have your order triple. You're ready to go in? Turn your page so I know that I can do it. These should not be difficult, they're just a little time consuming. Take up a little bit of paper. So the next 2 examples are the same material that we were just doing. You just have to set up the equations first. The equations are not given to you. So example 3, find the quadratic equation y equals ax squared plus bx plus c, whose graph passes through these following points. So we have 3 ordered pairs. We need to take these 3 ordered pairs and make 3 equations. So I'm going to think about the first ordered pair being like x1, y1. Second ordered pair, x2, y2. And the third ordered pair, x3, y3. So using which ordered pair it is, that tells me which equation I'm going to have. I'm going to have 3 equations. Equation 1, equation 2, and equation 3. I'm getting those equations from y equals ax squared plus bx plus c. Equation 1, I'm going to get by plugging in the first ordered pair for the x and y into this equation. So y in equation 1 is 5 equals a, I don't know, x is negative 2 squared plus B, I don't know. X is negative 2. Plus C, I don't know. So I'm plugging in the X and the Y into the equation and leaving A, B, and C as our variables. Do the same thing with X2, Y2. My Y2 is 5. We don't know A. X is negative 1. Square it. Plus B times negative 1 plus C. And then our third equation, the Y is 1. A times 0 squared plus B times 0 plus C. So 3 equations, 3 variables. Now I'm going to take those 3 equations and just simplify them so they're a little bit easier to look at. Simplify those 3 equations. I'll square the negative 2, get 4A minus 2B plus C. Square the negative 1, we get A minus B plus C. In equation 3, all those zeros cancel out, we get 1 equals C. So if you have C equals 1, we already know one of the answers. What should we do with that? Plug it in where? If I take C equals 1, I can plug it in both in equation 1 and 2. So my new equation 1 is now 5 equals 4A minus 2B plus 1. Equation 2, 5 equals A minus B plus 1. So I'm just substituting. I also feel like I want to move the 1's over to join the 5. I'm going to subtract 1 from each side to join that 5. So 4 equals 4A minus 2B, and 4 equals A minus B. So now I have 2 equations with 2 variables. We can just use substitution or elimination. What should we do with the A's or the B's? What should we do? What do you think? Get rid of A's or B's. What do you think? A's, what am I multiplying? Try that with words. What am I going to multiply by? Negative 4. If it bothers you that I have the number first and the variables after the equal sign, you can just switch the sides. That's okay. It doesn't bother me, but if it bothers you, just switch the sides. Oops, that's a negative. So I know C is 1, B is negative 6. What should I do with B equals negative 6? And C equals 1, sorry. What? Plug it into 1 or 2, yeah. I'll just, it doesn't really matter, so I'll just use 1. I plug in 1 and I get A equals negative 2. We're going to check in 2. Don't really need to check in 3 because C is 1 and that one's kind of checked already. When we're done, our goal was to find the quadratic equation. So we're going to plug A, B, and C back into the equation. So we'll have y equals our A was negative 2, x squared minus 6x plus C is 1. So that would be our answer. That would be the equation. You guys have your graphing calculator? So pull that baby out and graph that equation. Graph that equation we just got. No. So once you have that equation graph, this is just a self-check for you. Once you have that equation graph, if you go to the table of values, if you go to the table, so to get to the table, you do second graph. That's where the table is, second graph. Am I going too fast? Are we still typing in the equation? You go to second graph and you go to your table. The three ordered pairs that were given in the directions, those three ordered pairs, they all three have to be in the table if you have the correct equation. If two of them are in the table but the third isn't, then you've done something wrong. They all three have to be there. So, because I'll tell you right now, you could go through all of this and everything checks. And then you go here and it doesn't. What could have happened is when you wrote your first three equations, when you first set them up, you could have set them up wrong. And then you're checking all your answers off of wrong equations to begin with. And you may have done all the work right, but your equations are wrong. So this is a good check just to make sure that your equations were set up right. If those three ordered pairs are there, then you've done it right, which mine are. Do you guys have them? Negative 2, 5, negative 1, 5, and 0, 1. Do you have them in there? So this will be a good way of just making sure that your equations were set up in the first place. All right, if you're ready to go on, go to the next page. That was just for checking your answer. Last example, very similar to that one that we just did, only different equation. This time it's a circle. We have not learned how to graph circles in this form, but we can still write the equation in this form. You'll see we've got x squared and y squared. We've got dx, ey, and then an f equals 0. So we're still using this x1, y1 thing. x2, y2, x3, y3. We're going to set up three equations. First equation, we'll use our first ordered pair. And it's 0, 0. So wherever you see an x, put a 0. Wherever you see a y, put a 0. And then the second ordered pair, wherever you see an x, put a 0. Wherever you see a y, put a negative 2. So I just set up all my equations and then I simplified them so they're a little bit easier to work with. So I got f equals 0, I got 4 minus 2e plus f is 0, and 3 is 9 plus 3d plus f equals 0. And lucky for me, f equals 0, I already know f is 0. I already got that one. So I should use substitution. F is 0. I should use substitution. I should substitute F equals 0 into 1 or into equation 2 and equation 3. So I substitute in, and then I go look at equation 2 and 3. Oops, I forgot. I didn't even pay attention. There we go. Let's try that again. There we go. I substituted the 0 in. And then I look at equation 2 and 3, and what do I notice about like equation 2? Alyssa? There's just one variable now, so I can solve for E. And what do we notice about equation 3? One variable, I can already solve for D. So I'm just going to solve for E and solve for D. So E is 2. And D is negative 3. We can check it, but you're basically just plugging in 0 and 2, or 0 and negative 3 into the previous step, which I hope we haven't made any mistakes. I'm going to show you how to check it using technology also. So I'm going to write my equation. This one can't really even check. There's not even anything to do to check it. So the equation x squared plus y squared plus, we're going to plug in d. Oh, so that's going to be minus 3x. And then E is 2, so plus 2y. And then F is 0, so I don't have to write it, equals 0. So now if you were going to use your graphing calculator to check this, hold on. If you were going to use your graphing calculator to check this, so type this into y equals, what do you have to do to the equation? You got to make it say y equals, but we have a y squared. And we have a 2y. We have not reviewed how to complete the square, because that's what you have to do. Do you remember that phrase? So we're not going to do that today. We're not going to take the time to do that. You won't be able to check it on your graphing calculator. But have you ever used Desmos? Okay. So you're doing your homework. You won't be able to use Desmos on a quiz or test, but you can totally use it, on your assignments. Go to Desmos. And it does work very well on your phone. And you could also use this instead of your graphing calculator for the parabola ones too, the quadratics. But with Desmos, you can type in x squared and y squared. And it's very user-friendly for phone or computer. So I typed it in. It's a circle. That's what we were looking for. And then what ordered pairs should be on this circle? What's one of them? 0, 0. So I can go over and I can like touch it at 0, 0, and it shows me, yep, there's an ordered pair at 0, 0. Where's another one? 0, negative 2. Yep. And 3, 0. Yep. Those are not the only ordered pairs on the circle, but those are the ones they gave you, and all of them have to be on the circle, or I've done something wrong with my equation. Did you say challenge accepted and you're trying to type it in now? Okay. All right. So that's it for our notes. The assignment is in the book, and it's short-ish. I mean, it's 8 questions only, but some of them are a little longer, some of them are a little shorter, like the first example. And you all have like 19 minutes to work on it now. I have uploaded the Canvas